Yes, hello everyone. Welcome to Swiflearn, India's most sincere learning destination for class 1 to 10. In Swiflearn, we have 100% live and interactive classes. Personalized attention will be given to each and every student, where the maximum batch size is 6 students. A dedicated academic mentor will be allotted to track and work on your progress. We cover syllabus as per your school examination schedule, and also we handle custom requests. Our key features is we provide you with a detailed progress report card on monthly basis. Students can take Swiflearn academic test series, a scholarship exam conducted every Sunday from 9 a.m. to 9 p.m. Students can take unlimited practice tests, and all these practice tests are subjective as well as objective in nature for your school examination. So students, those who are new, book a free trial class today. Also, don't forget to subscribe our channel, hit the bell icon so that you will never miss any update. I am Shashank Sir, and today I'll be teaching you the fourth part of the topic cylinder, cone and sphere. So today's objective is conversion. We are going to learn conversion of solids. We'll solve on problems based on conversion of solids. We are going to learn combinations of solids, and we are going to solve the question based on combinations of solids. So all these things we are going to learn in the today's class. So let's recall what we have learned in the previous class. So these are the formulas which we have learned in the previous class. The total surface area of the sphere is given by 4 pi r square. Volume is 4 by 3 pi r cube. Okay, the total surface area is the curved surface area, which is 2 pi r square, and the top area, which is pi r square. Add them, you get 3 pi r square. Volume is obviously half of this. So 4 by 3 pi r cube into 1 by 2 will give you 2 by 3 pi r cube. Yes, this is cube. Okay, and the volume of a spherical shell is 4 by 3 pi into capital R cube minus small r cube. We have studied about different solid figures. Now let us learn about the conversion of solids with the help of some numerical problems. Let's take an example of a candle. Okay, it is melted and poured in the cast to form this dolls of rabbit. Okay, now what do we observe here? The volume of the candle, whatever the volume of the candle was, is equal to the volume of the rabbit. The fact that the change of shape does not change the volume of the object. Let the manufacturing units make different designs, be it a chocolate, candies, doorknobs, okay, clay models, wax models, anything. On cooling, you will obtain a candle in the shape of a rabbit. The volume of the new candle will be the same of the volume of the earlier candle. Now let's solve some problems based on the conversion of solid from one shape to another shape. Let's take an example. A cone of height 24 centimeter and radius of the base is 6 centimeter is made up of modeling clay. A child reshapes it and forms into a sphere. Find the radius of the sphere. Now see here, it was a modeling clay. Okay, it is a cone. Now the cone is reshaped to a sphere. So the volume of the cone is equal to the volume of the sphere. Let HS and HC and RC be the height and radius of the cone. Let HS and RC be the height and radius of the spheres. Now the volume of the cone is given by 1/3 pi RC square into H. Volume of the sphere is given by 4 by 3 pi. Okay, sorry, the sphere doesn't have any height, it only has the radius, pi RS cube. Okay, yes. Now these two are equal. Cancel out this, cancel out pi. How much is RC? The radius of the cone is 6 centimeter and the height is 24 centimeter. So 6 into 6 is 6 square into 24 is equal to 4 into RS cube. This is 4 into, if it goes the side, you take the transpose, it will become divided by 4. Okay, so RS cube is equal to 6 into 6 into 24 by 4. 4 1 ja, 4 6 ja. RS cube is 6 cube. This implies what? This implies RS is equal to 6 centimeter. The radius of the sphere is 6 centimeter. Yes. Okay. So they have solved in a different approach, but ultimately we get the same answer, which is 6 centimeter. The approach which needs to be used is volume of the cone is equal to volume of the sphere. No matter there is a change in shape, but the volume still remains the same. A copper rod of diameter 1 centimeter and length 8 centimeter is drawn into a wire of length 18 meter of uniform thickness. Find the thickness of the wire. Okay, so there is a rod, copper rod. What is the diameter? The diameter is 1 centimeter. Okay, of length 18 meters. Okay, 18 meters means how much? 1800, sorry, 1800 centimeters, because 1 meter is equal to 100 centimeter. 18 into 100 is 1800 centimeter. This is recast into a thin wire. Okay, is drawn. Okay, so see here, sorry. A copper rod of diameter 1 centimeter and length 8 centimeter. Okay, this is 8 centimeter. Okay, yes. Is drawn into a thin wire of 18 meters. The length of the wire is 18 meters. Let me convert this in centimeter, which is 1800 centimeters. 1 meter is equal to 100 centimeter. Find the thickness. Thickness means find the diameter. Yes. So the volume of the rod is, let R and RH be the radius and height of the rod, copper rod. Let RW and HW be the radius and height of the wire. So volume of the rod is equal to volume of the wire. Volume of the rod is given by pi RR square H. This is given by pi RW square into HW. This is HR. HR. Yes. Now pi gets cancelled. R square H. How much is R? Okay, diameter is 1 centimeter. So 1 by 2 whole square. Height is 8 centimeter. Radius, we don't know. Actually, we want the diameter. First, let us calculate radius. Then let us find the diameter. Height is 1800. Now, on simplifying this, what do we get? 1 by 4 into 8 divided by 1800 is equal to RW square, radius of the wire square. Okay, 4 ones are 4 twos are, 2 ones are 2 nines are. This is nothing but 1 by 3 square into 10 square RW square. Okay, so RW is equal to 1 by 3 into 10, which is 1 by 30. RW is how much? RW is, radius of the wire is 1 by 30 centimeter. Now you want the thickness. Thickness is nothing but diameter. TW is 2 times RW, which is 2 times 1 by 30 is equal to 1 by 15 centimeters. You want in millimeters, you can convert this in millimeters, like 1000 millimeters by 15. Divide it, you will get in millimeters, or you divide it, you get in centimeters. Yes, this is the thickness of the wire. Yes, 1 by 15 centimeter. We have solved it right. Yes. Okay, now this question is like not based on the topic. So this is based on the flow rate and all. So you want, you can try it. Otherwise, it's okay not to solve this. So let's study about the combinations of solids. Combinations of solids, surface area of the combination, volume of the combination. Okay, problems on surface area combinations of the solid, surface area of combinations of solid. In our day-to-day life, we come across a number of solids which are made up of combinations of two or more of the basic solids. Yes, you must have seen a truck with a container filled on its back is carrying oil or water from one place to another. Yes, it is in the shape of any four basic solids like sphere, cube, cuboid, cylinder, etc. You may have guessed that it is made up of cylinder with two hemisphere at its end. Yes, you are right. Similarly, while driving, you may have seen some big and beautiful buildings, monument made up of combinations of solids as mentioned earlier. If for some reason you wanted to find the surface area and volumes or capacities of such subjects, how would you find it? In this module, you will see how to find, we will learn how to find the surface area and volumes of such objects. Now let's consider this container given below. How do we find the surface area of such solid? It's easy by splitting it into the solids, shape of the solids which we know, which we can calculate the volume and areas. Okay? Yes. You can see that the solid is made up of cylinder with two hemispheres stuck at either end. Yes, it is made up of cylinder with two hemispheres. So the total surface area of the new solid is sum of curved surface area of the individual parts. The total surface area of a new solid is equal to curved surface area of the hemisphere, curved surface area of the cylinder, and curved surface area of the hemispheres. Will give you the total surface area. Yes, now let us consider another situation. Suppose we are making a toy, putting together a hemisphere and a cone. Sir, इसको उल्टा कर दो, ice cream हो जाएगा. Yes, it is another example. A toy is also an example. So let us see the steps. What we do you going through? First, we would take a cone and hemisphere and together bring their flat surface together. Now, if you want to find how much paint would we require to color the surface area of the toy, what would you need to know or what we need to find? We would need to find the total surface area of the object, which is given by curved surface area of the hemisphere plus curved surface area of the cone. If you add this, you get total surface area of the toy. यस सर इसका बेस एरिया क्या हो गया बेस एरिया base is getting hidden right you needn't paint it right only you need to paint the curved surface area of the hemisphere and curved surface area of the cone इतना ही पेंट करना है तो बेस एरिया नहीं कंसिडर करना है yes so let's solve a problem based on this Rashid got a playing top okay as his birthday present, which is surprisingly had no color on it. He wanted to color with his crayons. The top is shaped like a cone surmounted by a hemisphere. The entire top is 5 centimeter in height. Okay, and the diameter of the top is 3.5 centimeter. Find the area that he has to color. Okay. Now देखो यहाँ पे थोड़ा डायग्राम कंफ्यूजिंग हो सकता है. Now it is like this. The top is a hemisphere. Okay, exactly sphere का half hemisphere. यहाँ पे थोड़ा ज्यादा दिख रहा है. But yes, you assume it is a hemisphere and it is surmounted on a cone. Okay. Now the total height is 5 centimeter. The diameter is 3.5 centimeter. Okay. So radius is half of that. Okay, half of 3.5 is 1 point, half of 3 is 1.5, half of point is 0.25. So this height or the radius is 1.75 centimeters. If you subtract 1.75, you get the height of the cone, which is 5.00 minus 1.75. Yes, 5 minus 1 minus 1 is 3 point, all from 9 last from 10, 2.5 centimeters. Sir, आपने ये calculation कैसा किया? Well, I use the technique of Vedic maths. If you want to learn Vedic maths, okay, book a free trial class today. We'll teach you how it is done in the much easier way. Yes, this height, okay, So find the area he needs to cover. The total surface area of the toy is given by curved surface area of the sphere, hemisphere, plus curved surface area of the cone. Curved surface area of the hemisphere is given by, yes, curved surface area means should not add the top, okay, only the curved surface area. Curved surface area is 2 pi r square. Yes, curved surface area of the cone is pi r l, where l is the slant height. Okay, now quickly find l कैसे निकालते हैं. Okay, the height is 3.25. The radius is given by 1.75. Find the square root, you will get the L, the slant height L. So 3.25 square. Okay, how to find this? It is simple, 32 into 33. Okay, I'm using the technique of Vedic maths. So 3.25 square, it is like finding square of 325. It is ending with 5, so it is 25. 32 times the next number is 33. So 3 2s are 6. 33 into 2 is 66. 33 into 3 is 99. 99 plus 6 is 105. Okay, 105,625 is the square of 325. Now decimal point after 4 numbers, so 10.5625. Okay, and 1.75, again the same thing. Okay, so 1.75 is nothing but 17, next number is 18. Okay, so 1 into 1 is 1, 8 plus 7 is 15, 7 8s are 56, 22 is carried, 306 point. Okay, so 30625, put a decimal here, so it is 3.0625. Add them all, you get 13 point, okay, 625, 13.625. Okay, take the square root of this, you get L. How to take square root of this? 13.625. Okay, yes, for a while now. Okay, so it is like, I'll take like this, 13.13625 divided by 1000. Okay, now square root of this you find by the long division method. Okay, or let's take the help here, what like we will get the calculated values. So the cross sectional area of the hemisphere is, okay, so it is 2 pi r square. So 2 into 22 by 7 into 3.5 by 2 into 3.5 by 2. You do this, you get the cross sectional area of CSA, curved surface area of the hemisphere. Okay, subtract this, you get the height. Okay, now use this to get the slant height, which is approximately equal to 3.7 centimeters. The curved surface area of the cone is given by pi r l. Do this calculation, add both the values, you get 39.6 square centimeters. Okay, now this type of calculations are a bit large, are a bit time consuming, so that's why they have a lot of marks. So students, what I suggest you to try solving these problems at the last, because they are very time consuming. Okay, so you may solve very less problems and skip out easy problems, so that's why try to solve them in the last. A decorative block shown in the figure is made up of two solids, a cube and a hemisphere. The base of a block is a cube with the edge 5 centimeter and hemisphere is fixed on the top as the diameter is 4.6. Find the total surface area of the block. Yes, total surface area. Now देखो ये ऊपर, okay, if you find the total surface area of the block, okay, this is not related to the problem because we are only studying cones, spheres and cylinder, but I'll give you a clue how it is done. Find the surface area of the block. Okay, how to find the surface area of the cube? Okay, it is 6a square, 6 side square, 6 into 5 into 5 will give you surface area of the block. But see here, the top surface, there is a sphere. The circle is hiding. So this we needn't consider. So we need to subtract this, which is pi r square. R is equal to 2.1 into 2.1. This will give you the surface area of the block with the hole in the between, and the curved surface area of the hemisphere is plus 4 pi r square. R is equal to 2.1 into 2.1. So do all these calculations, you will get the answer. Okay, yes. So let us see if they have given any steps. Okay, they have directly given the answer. So guys, do the steps. Okay, so do this. So pi is 22 by 7. So 7 1 is 7. 7 3s are 21. So 0.3. Okay, so same into 22 into 0.3. Yes, do this calculations. You get the answer, which is equal to 163.86 square centimeter. Yes, what about this? A cubical block of side 7 centimeter is surmounted by a hemisphere. Okay, this is a cubical block. Okay, so it is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Okay, a cubical block. Okay, तो ऊपर square है. Yes, this is a square. So what can be a greatest diameter? Okay, it can have, so it can have this. Okay, the maximum diameter can be 7 centimeters, right? Yes. Find the surface area of the solid. 7 centimeter is the greatest diameter, and the same thing. Okay, see the find the surface area. The surface area is given by 6 into 7 into 7 of the cube minus the circle, which is pi into 3.5 into 3.5 pi r square, which the base the sphere has taken, and add the curved surface area of the, this is the base area of the hemisphere, subtract it and add the surface area, curved surface area, which is 4 into pi into 3.5 into 3.5. Do this, you will get this area. Yes. Okay. Yes. So volume of combinations of solids. So it may be noted that in calculating the surface area, we have not added the surface area of the two constituents. Tell us why. Because some part of the surface area disappeared in the process of joining them. Yes, because they are overlapping, we are not considering. However, this will not be the case when we calculate the volume. The volume of the solids formed by joining two basic solids will actually be the sum of the volume of the constituents. When we are joining two objects, the volume will be same. Volume of the object will be the volume of object 1 plus volume of object 2. Shanta runs an industry in a shed which is in the shape of a cuboid surmounted by a half cylinder. If the base of the shed is of dimension 7 meters into 15 meters, okay, and the height of a cuboidal position is 8 meters, find the volume of air that shed can hold. Further, suppose the machinery in the shed occupies a total space of 300 meter cube. There are 20 workers, each of whom occupies this much space on an average. How much air is inside that shed? Okay, so volume of the industry, volume of the shed कैसे निकालना है? Volume of the cuboid, which is length into breadth into height. Volume of the cuboid is 7 into 15 into 8 plus volume of the half cylinder. Okay, 1 by 2 pi r square. R is 3.5 square. Okay, into the height is 15 centimeter. This is the volume of the industry. Okay, calculate this, get the answer. Okay, find the volume of the air that shed can hold. The volume of the air that shed can hold is this much. Simplify it, write the answers in meter cube. Now, this, okay, machinery is occupying some space. So minus 300, okay, and minus 20 workers are there who occupies space about this on an average. So volume occupied by the workers is 0.08. Okay, and there are 20 workers, each of whom, each means you need to multiply it by 20. Then how much is the shared area? This number minus this number minus this number. Calculate, it will take some time. Do the calculation. You will get the volume and the answer will be in meter cube. Got this? Yes. See, this is the volume of the factory minus 300 minus 1.6, which is this volume of the 20 workers. You do this, you get the answer. Let's do a case study. Suppose that the festival session is coming and hemispherical dome of an temple needs to be painted. Yes, you and your friends talk to the painter and tell the dimensions of the dome. If the circumference of the base of the dome is, circumference of the base, circumference of a circle is given by 2 pi r is equal to 17.6. Okay, then the painter charges, the cost is 5 rupees per 100 square centimeter. Find the cost of painting. Find the surface area. What is equal to r? R is equal to 17.6 divided by 2 pi. Pi is 22 by 7. Yes, 11 twos are 22, 11 ones are 11. Point 11 six are 66. 2 ones are 2. 2 eights are 16. 2 ones are 2. 2 fours are 8. 0.4 into 7. 7 fours are 28. R is equal to 2.8 centimeters. Meters. Sorry. See here. The dome is this much meter. So 2.8 meters. Radius of the dome is this. Find the cost of the painting. So dome outside, the curved surface area of the dome is given by 2 pi r square. Okay, so 2. How much was the radius? How much did we find just now? It is 2.8 centimeters. R is equal to 2.8 meters. Curved surface area of the dome is given by 22 by 7. Okay, 2 pi into 2.8 into 2.8 r square. 2 pi r square? Yes. 7 on the 7, 7.4 are 28. Now find the curved surface area. Now this is in 22 into 2 is 44. Okay, zero point 0.4 into 2.8. 2.8 into 0.4. 4 twos are 8. 8 fours are 32. So yes, add them, you get 112. Decimal after two numbers, 1.12. So 1.12 meters into 44. 44 twos are 88. 44 ones are 44 plus 8 is 52. 44 ones are 44 plus 5 is 49 after two numbers. So 49.28 meters square. Area is 49.28 meters square. Convert this meters into centimeters. 49.28 meters square. This is 1 meter square, which is meter square. Now 1 meter is 100 centimeters. Uska square. 49.28. 100 square is 100 into 100 centimeters square. Now, per 5 rupees per 100 meter square. Okay, per 100 centimeter square, he is going to charge 5 rupees. So it is 49 into 100, which is 4928 into 5. Per 100 centimeter square is 5. So 4928 into 5. 5 fours are 20, 9 fives are 45, 5 twos are 10, 5 eights are 40. Add them, you get 24640 rupees. So it is 24,640 rupees for the cost, will be the total cost for painting the dome. See, we have done it right. Okay, some applications, a goldsmith melting a bar of gold, transforming into jewelry. Okay, a kid playing with clay shapes into different toys. Okay, so what have we learned today? We have learned conversion of solids, conversion based problems, and all these things we have learned in our today's class. So you can solve this more problems. Okay, yes, you can solve these problems. And that's all for today, guys. So we'll stop here then. Bye bye. Have a nice day, everyone.